In this lesson, we will evaluate a finite geometric sequence, which means we're finding the sum of the first however many terms of the series. So again, this is something that I would write down. Specify in your notes that this is for a finite series. So again, we're finding the first n terms of that geometric sequence or series. So we're finding the sum, in this case, of the first 6 terms of this sequence. We obviously know that our first term is 4. Again, to find that common ratio, we're taking 12 divided by 4, which is 3, or 36 divided by 12, which is 3, etc. So we know that that R value is 3. So to find S sub 6, which means the sum of the first 6 terms, we're taking our first term, and then 1 minus 3 to the 6th. And then that's over 1 minus R, so 1 minus 3. So that will be the sum of the first n terms. So my numerator, I have 4 times 1 minus, and then we need to find 3 to the 6th, which is 729. And then 1 minus 3, of course, is negative 2. I can reduce at this point if I would like to. It's completely up to you. I'll go ahead and wait till the next step. I've got 4 on the top, and then 1 minus 729 is negative 728 over negative 2. And again, I can reduce at any point. I'll go ahead and reduce this to 1 and to negative 2. So really, I'm just taking negative 2 times negative 728, which is 1456. So that would be the sum of my first 6 terms. Again, this one would be easy enough that I wouldn't have to use this formula. I could just go ahead and find the 5th term by multiplying by 3 and the 6th term by multiplying by 3 and then adding those together. But again, using that formula is pretty easy as well. So this one's written a little bit differently because it's written in summation notation. But keep in mind that this part is just my a sub n equals 3 times negative 1/3 to the n minus 1. That's essentially what is happening here. Notice instead of n, they have I. That's because they're using that index notation here. But that tells me that my first term is 3 without having to do any work at all, and that my ratio is negative 1/3, again, without having to do any work at all, which is nice. So now if I'm going to use my formula to find the sum of the first n terms, and of course n here is going to be 8, we're going to find the sum of the first 8 terms. I'm using my first term of 3, and then 1 minus negative 1/3 to the 8th, and that's over 1 minus r, so 1 minus negative 1/3. Let's do a little bit of cleanup. So on the top I have 3, negative 1/8, or negative 1/3 to the 8th. Negative 1/3 to the 8th is positive 1 over 6,561. And my denominator, I actually end up with 1 plus 1/3, which is 4/3. On the numerator, I'm taking 1 minus 1 over 6,561. So if I changed 1 into 6,561 over 6,561 and I subtracted, I would get 6,560 over 6,561. And this is divided by 4/3. And so instead of dividing by 4/3, I'm going to multiply by 3/4 because it's easier than having so many fractions. So again, S sub 8, and I've just got a hot mess of stuff here, and I'm going to see if I can reduce anything. So I did some reduction here between these two values, and I got 1, and on the denominator, 2,187. I reduced the 4 and the 6,560. The numerator became 1,640. And now, of course, I still have this 3 out front that I haven't addressed yet. And so I'm going to reduce the 3 and the 2,187 to get 1 and 729. And so now my final answer is 1,640 over 729. So that is the sum of the first 8 terms. So this is kind of a mess, and yet it's so much better than actually writing out the first 8 terms and then finding the common denominator and then adding all of them together. For this one, we have another geometric series, and yet we don't know what n is. N equals question mark. We don't know what it is. We know what the last term is, but we don't know what the value is. So we're going to have to do a little bit of math to find what n is, or how many terms exactly we're finding the sum of. We can, of course, find r, just as we did before. 6 divided by 3 is 2, 12 divided by 6 is 2, etc. So r is 2, and obviously my first term is 3. So I'm going to use that formula that says a sub n is equal to the first term, which is 3, times the common ratio, which is 2, to the n minus 1. So I'm going to use this and say, let's go ahead and put 1,536 on the left side so that I can figure out what n is. So I've got 3, 2 to the n minus 1. I'll divide each side by 3. And from here, I have 512 equals 2 to the n minus 1. Now, we talked previously about how to solve this because that n minus 1 is a exponent. So I could take log base 2 of each side. The other way to do a question like this is if 512 can be written as 2 to a power, and in this case it can, then once I get the same base, I can drop the base and say 9 is equal to n minus 1, and so by adding 1, I know that n must be 10. So 10 is my n value, which means that's how many terms I'm finding the sum of. Which means now I'm going to find the sum of the first 10 terms, and I'm going to do that by taking a sub 1, which is 3, and then 1 minus 2 to the n, over 1 minus r, so 1 minus 2. So on my numerator, I have 1 minus 1,024, and this is 1 minus 2, which is negative 1. So this is now going to no longer be a fraction because I'm just going to move that negative and say that's negative 3 times negative 1,023, and multiplying those values together, I get 3,069. So my sum is 3,069. Here are 2 for you to try on your own, so try them both and then press play to check your work. So again, looking at this one, very similar to the last question that we did, we don't know what number that is, what number of the series that is. So I would actually have to go ahead and find that 768 is equal to the first term, and then the difference, which is 6 divided by 3, or 2 to the n minus 1. So I would divide each side by 3, which is 256 equals 2 to the n minus 1. 256 is a base 2 number, so it's actually 2 to the 8th equals 2 to the n minus 1, which means 8 is n minus 1, which means n must be 9. So to find the sum of the first 9 terms, I would take my first term, which is 3, 1 minus 2 to the 9th, over 1 minus 2. So I have 3, and then 1 minus 2 to the 9th, which is 512, and then 1 minus 2 is negative 1. So that gives me 3 times negative 511 over negative 1, so I'm just going to call that a negative 3. I'm going to multiply those two values together and get 1,533 is my sum. For the next, obviously, that n value is 7, so we're finding the sum of the first 7 terms. The first term I would actually have to find, so I'm going to plug in, actually no I don't, just kidding. My first term is 8. So that's 8, 1 minus r, r is 1/4 to the 7th, over 1 minus 1/4. Again, that is my R value. So that gives me on the numerator 8 and then 1 minus 1 over 16,384. And that's over 1 minus 1/4, so that's 3/4. So that gives me 8. And then all of this mess, which would be 16,383 over 16,384. And instead of dividing by 3/4, I'm going to multiply by 4/3. Hopefully these will reduce a little bit. So the 4/3 and this giant fraction did end up reducing. I'm still now going to reduce that 8, and so my numerator is 5,461. Dividing both of those by 8 gives me 512 in my denominator, and that is the sum.